So the next presentation is going to be Carrie Eberle. She's our systems agronomist. She's in the Department of Plant Science at the university, but she's housed here at SAREC, so she gets to spend all her time with us.
And it's still not working. Okay, so I'm going to sit so that I don't block your view of the screen, because I worked very hard to kill you all with PowerPoint, as researchers like to do. So I'm going to give you an update on our hail study that we put out here last year. So as many of you may remember, last year's field day was pretty boring because all of our crops were dead and we didn't really have anything to show you. And one of the things we talked about was a hail study that we put in response to that hail damage. So this study is really a collaborative effort between every single person who works out here at SAREC. It's very much a team project. And we also got support from the Rapid Response Agriculture Fund. So, you know, there's a lot of people really backing this project, and we hope that you all find it interesting and helpful to you. So last year, July 28th, for those of you who are local, you probably remember we had a very large hailstorm that came through, and it hit SAREC and our neighbors. And one of the results of that hail damage was that in our irrigated corn, we lost about 90% of our leaf material and 50% of our tassels in that corn. And we were at green silk at the time, so we hadn't pollinated yet, and we really lost any potential to produce a grain crop or a silage crop from it. So we had sticks in the field, which I know the pictures don't show it very well, that had no value. And so we found ourselves in a situation where we do production agriculture out here. We have cattle that we have to feed, and our corn is really important for that. And so we were trying to understand and figure out, how do we come up with a solution to this problem? How do we salvage our fields? How do we still get feed production for our animals? And so while we were struggling with some of these questions, what we also found was that our neighbors were really struggling with these questions too. So we were getting calls from some of our local guys asking what to do in their fields and what was the best option for them. And so what we decided to do is invite some producers in and meet with our researchers and our farm staff and have a conversation about, you know, why don't we have good answers for these questions, and what are our questions, and what are ways that maybe SAREC can take advantage of the situation and come up with good solutions for you guys. And that is really the foundation of the hail study. So the questions that we were asking was, first and foremost, what do we do with the corn that's out in the field? We've got sticks out there, it's not worth taking a silage chopper through and chopping it, so how do we manage it? Then after that, is there a cover crop option that is going to work best for this kind of late season hail damage? Best to protect the field, so the wind blows out here, you know, what's our best option to protect the field from that? What about cycling nutrients? So technically we left every single thing in the field that we put in the field last year. So we didn't harvest any grain, we didn't harvest any silage. So all of our fertilizer inputs, those should still be there. So is there a system that we can implement that is going to capture those nutrients and make them available to us in the following crop season? And then finally, you know, animal feed. Like I said, we do have cattle out here, so what is going to be our best option if we have a livestock operation and we need to come up with an emergency feed source for them? And then from there, we also wanted to know how those decisions that we made last fall were going to impact our corn this year. So, you know, crops don't exist in a single season, and all of these things come back and affect us in the following year. So, you know, we're taking the study through fall corn harvest this year, and we're going to get a complete picture of how those different management decisions impact those things. And then finally, we do have an ag economist on board, and we really want to understand the complete economic picture for what we're doing out there, all the inputs and outputs, and you know, how those things tie together with a livestock operation or not a livestock operation, to really try and get our best idea of what's worth the investment and what's not for you guys. So those are our questions that we're trying to address with the hail study. How we're doing it, as far as corn management, what we decided to do is come up with 4 different management treatments for those standing corn stalks in the field. So the first one was we did nothing. So we left the stalks in the field. If we planted a cover crop, we just direct drilled into that standing corn. The second option was we took a stalk shredder and went over that corn and chopped up those corn stalks and left all that material just laying in the field where it landed as we chopped it. The third option was we took our disc and we just plowed under the standing corn stalks as they were. We went over it with 2 passes, and that's all we did. And then the final option was first we hit the stalks with the stalk shredder, and then we came through and disked the field to cultivate those chopped stalks into it. After we did our tillage management, we came through and we applied 6 different cover crop treatments. So we ended up planting all cereal forages because we had some residual herbicide carryover that we couldn't put any broadleafs into the field, which turned out to be a little bit of a blessing because it kept things a little bit simpler for us. And all of those cover crops were put in each one of those 4 corn management treatments so that we get a full effect from each combination. So our forage crops were winter rye. We did have a fallow treatment so that we can see what happens if we didn't put any cover crop in. We planted triticale at a half seeding rate, so at 60 pounds per acre. And then we had a full seeding rate of triticale, so it was 120 pounds per acre. We also planted sorghum sudan grass, and then finally a winter wheat. So those were planted August 20th. They were allowed to grow, and in November, we put cattle out on the field. So again, our cattle were getting hungry, and we had good biomass out there for them, so we put them out there to graze. But at the same time, we did put grazing exclosures out as well. So we have areas of the field that were grazed and that were ungrazed. So again, we can look at if you have a grazing operation, what's the impact? If you don't, what's the impact? So what we're hoping to learn from this, so we have kind of our 3 main treatments, right? Our corn management, our cover crop type that we put in, and then our grazing. And what we're really looking at is biomass. So as far as the cover crops go, how do these things affect biomass production in the fall and in the spring? We're looking at soil fertility. So like I mentioned, the hope is that we're able to maintain a lot of those nutrients in the field. So we're trying to follow those nutrients through from the fall to the spring through the corn crop and see, if these treatments affect that fertility. We're also looking at forage quality. So, do some of these treatments impact the quality of the forage that's in the field? The economic impact of all of them and the combination of all of them. And then our corn yield. So ultimately, it all comes back to the corn, right? We want to see if there's any impact this year on how our corn performs. So we do have some preliminary data and information. Overall, it looks like we're going to learn something, which is good. We won't have the final results until this winter, but we are seeing some trends in our biomass production. So last fall, we sampled biomass, and what we saw was that all of the different treatments impacted what our biomass was doing in the field. So that means that we have some control for how we make our management decisions depending on what you need for your biomass. So this graph is showing the effect of corn management. So the disc, drill, shred, and shred disc treatment on fall biomass. And the blue circle is showing our shred and our shred disc treatment. So we tended to have higher biomass production in those 2 treatments. If you ask me why, I'm going to tell you I'm not sure yet, but I can make some things up later if you want me to. I have some ideas. But, it's there, it's a real thing, and we're still in the process of figuring out how to interpret it. This graph is showing the effect of the cover crop type on fall biomass. So again, at the bottom, going from left to right, we have rye, sorghum, triticale at the half rate, and then wheat at the very end. So you can see way down at the very bottom is our sorghum. We had very, very little biomass production from our sorghum crop. It was planted late in the season. Not really an ideal time to plant sorghum, so the crop got froze out pretty quickly. It just didn't perform for us. But we also see in the blue circles here, our rye crop and our triticale seem to have a little better biomass production in the fall than our other two winter cereal crops. So if you're really interested in a fall producing crop, those may be a better option for you. Now in the spring, both of these trends went away. So by the time we took spring biomass sampling, we weren't seeing corn management or cover crop type affect our total biomass production. With biomass, we also looked at forage quality, and again, well, what we actually saw with that was that nothing impacted forage quality. So when we looked at the quality of the cover crop that was out there, what we found was that across all those treatments, we had really high quality forage. So we had 17 to 29% crude protein in those, and there really weren't any differences between any of the cereal rye that we put out there. And then as far as economics go, so again, we're still looking at trying to put that whole picture together. But we do see differences in our corn management and our cover crop selection for economics and how those things interact as well. So it's not as simple as just knowing which one of those things is the least expensive. So our corn management treatments, the disc treatment was the cheapest thing. So where we just disked under the corn stalks only cost $27 per acre. Our shred treatment cost the most at $23 or $43.50 per acre. And you may be looking at the drill treatment and say, you just direct drilled into the crop, why did that cost more? That's because we had to hit it with some herbicide to control the weeds. So the cost of the herbicide in our no-till treatments made those treatments more expensive than their counter treatment where we disk the ground under. Cereal forages, wheat cost the least per acre. We're looking at $19 per acre for our wheat. The triticale by far was the most expensive seed that we got, which sometimes I still wonder if our seed dealer overcharged us a little bit for it. It cost us $60 an acre to seed that triticale. So again, if you're just looking at this, you may say, well, why would anybody grow triticale? It's way too expensive to get that seed. But again, we want to look at how that comes out on the other end of things, right? So if we're looking at it from a grazing perspective, how much biomass are we getting? How many animals can we feed on these different crops? And so that is what this table is looking at. So here we have the cost per animal unit day. So that is when we take our biomass, we look at how much is produced per acre. We look at our cost of our management treatment and our seed treatment and put all those things together. And per animal unit day, what did it cost to produce that feed? So this table goes from cheapest to most expensive, top to bottom. And what you hopefully are noticing is that we see our cover crops grouping together. So all of our wheat is up at the top. So that is our cheapest production. Then we have a rye falling out in the middle and triticale down at the bottom as being more expensive to produce for those feeding units for the animals. With that, the corn management, which are the second row of colors, you see those are really interspersed throughout there. So that management treatment that we applied really didn't have a strong driving factor for the cost of our feed that we were producing on those fields. And then finally, so this was for the fall, and we did look at alfalfa hay costs for the fall. So at that time, alfalfa we figured was between $1.17 and $1.89 per animal unit day. And that falls out at the bottom of our chart. So about half of our systems were less expensive than that. Our wheat disc was only 75 cents per animal unit day. But all of these options are competitive with alfalfa. So, they may be different from each other, but depending on what you're doing in your system, they're all competitive with what your hay supplement would be. And then as far as soil fertility and corn yield, we are seeing some trends that all of these treatments do affect that stuff. So I think we're going to see some really interesting things coming up here in the winter, but it's still to be determined. We have to get that corn out of the field and do some more sampling. So that's kind of where we're at with the hail study. We do have a couple posters set up that have a lot more information on them of where we're currently at. And then we're expecting to have the final results out this winter. So we'll be getting those out to you and publishing them. And I just want to again say thank you to the SAREC crew for their help with this, to the producers who worked with us to get the study put in, and to the Rapid Response Agriculture Research Fund. They really contributed. And I just think this is a good project. We're hoping to do more stuff like this where we can get projects out here that hopefully give you guys good information that you can use in information.